This is a recording for the movement test. We will be simulating roll, pitch, and yaw with our force feedback simulation on the Microsoft Visual Studio. And the first test we will be doing is sending roll forward 15 degrees. But 15 degrees for the bowl to move is actually translates into one of our motors moving 100 degrees. So just make observation that this tape right here indicates the starting position. It's lined up with the bottom blue tape, and this motor right here, the blue tape, is lined up with the bottom black tape. Basically, we're just going to send that roll forward 15 degrees and see that it translates into 100 degrees for each of the motors. So, Ed, why don't you go ahead and send it roll forward 15 degrees? Okay, I have a protractor on me where we can estimate about how much it rotated. So this right here is approximately 100 degrees, and you know that because this is a little bit past 90 degrees. And then we're going to check this one too. Same thing. You can approximate this to be 100 degrees because it's a little bit over 90. And if I was able to point this out to you, it's actually very close to 100 degrees, which is in line with our specs, because our specs is to have our pitch movements be within 10% of whatever angle we're trying to rotate it. So now this next one, we're going to rotate it back to simulate roll 15 degrees in a negative direction. So as you can see, they return to its starting position, which proves that it can rotate forward and backward, which is plus or minus 15 degrees. Next test we will be doing is pitch 15 degrees, which is this motor right here. In pitch 15 degrees, only one of the motors move, and it's going to be this one right here. So this is going to be the exact same test as the roll, except with just one motor. So why don't you go ahead and go for it. So just again, about 100 degrees right there. So send it back. Okay, so one more test is yaw. And yaw just involves only this motor because of how it's positioned in our base. So the thing about yaw is our yaw movements have to be plus or minus 120 degrees, which translates into 750 degrees on this motor itself. So it's going to have to make 2 full revolutions and then 30 degrees past that to simulate the 750 degrees. So why don't you go ahead and how we figured out these calculations was by using time delay. We estimated time delay it takes for these motors to spin. Okay, so this camera is not clear enough for me to demonstrate, but starting from, okay, I can't hold this with one hand. So if you hold this camera for me, or that too. Okay, so it's about right there. So this is the 180 degree mark right here, or 0, and where this points to right there. That's 150 degrees or 30 degrees actually. So this is actually right on point with what we are trying to do here. And now we're going to send this back to the origin by doing negative 120. One revolution. So on the second revolution, it should come very close to matching up with the blue tape. So there we have a little slight of error. Let's see, let's measure the angle here. this angle comes out to be a little bit close to 20 degrees. And if I'm not mistaken, um, 20 degrees is approximately less than the 10% range of 750 degrees. So this still falls within spec for testing. And what else is there for this testing procedure? That's it. So that was pitch, roll, and yaw. One from a force feedback simulator.